Inventive Podcast with acoustical engineer Trevor Cox.
Inventive.
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 Nose, shoulder, ribs, hands twice, I'm afraid. I've broken quite a few bones in my body. What about you? And if you've been that unfortunate, did you need to have trauma plates to hold the bones together to help them to heal? Now you might think I'm talking about medicine. And of course I am, but there's also an engineer involved because someone's got to design those plates, especially if you're going to use cutting edge materials. Someone like Greg Bowie, my interviewee from this edition of Inventive. And we'll also hear from author Emma Newman, who's taken Greg's interview and turned it into a fantastic fictional account of amateur espionage. Why? Because this is Inventive, where I chat with an engineer.
My name's Greg Bowie. I'm a manufacturing engineer at Invibio Biomaterial Solutions.
And ask a writer to create a story inspired by that conversation.
He took out a tiny plastic box, not much bigger than a SIM card.
My main role of work is development of composite trauma plates.
I need you to put this in the plate you print for the diplomat, and I need you to not tell a soul about it.
The characters are inspired, but not meant to be you.
Are you a spy?
You're not involved in covert operations to topple an authoritarian government, are you?
Not to the best of my knowledge.
What other secrets had he been keeping from her?
I didn't realise I was having a sex change in this storyline either.
The Inventive Podcast, mixing engineering fact and fiction.
An interesting concept, to say the least.
Inventive.
So what are you working on at the moment?
Carbon fibre reinforced plastic trauma plates.
What are they used for?
So if you imagine someone involved in an accident and they break a bone, then generally trauma plates actually help fix the bone back in place whilst the bone mends and heals across the break as such. Historically, I've always been made out of metal, so this is a new technology.
And what advantages does that have over, say, titanium steel?
If you have a metal plate in the body, when that patient is x-rayed, all the x-ray just gets glare off the metal that's in the patient. So when we have this carbon fibre reinforced plastic plate, the benefit of that is that they can actually x-ray through the plate and sort of see how that bone's developing and healing. And the makeup of our material is a lot nearer to how bone is. So with the plate in place, it enables that break to flex, and the actual flexing motion between the break actually encourages bone growth. So the patient generally heals quicker and sooner and has a better recovery period, shall we say.
And this material you work on, you're working on small things to go in people's bodies for bone surgery, but they're also used on a vast scale, aren't they? They're used in underwater pipes.
Yeah, sort of currently in the process of developing plates that go onto your toes. So that's probably the smallest size plates that we'll ever do. Yet the very same material that creates that goes on to wrap around a pipe that's up to probably 6 inches diameter by up to maximum of 6 kilometres long that can then sit at the bottom of a seabed.
It's amazing a material can work across such large scales. I was kind of imagining you've got some sort of giant that you're working on their table, but even that wouldn't be that big, would it?
No, we haven't got a Jolly Green Giant or James a Peach or whatever working around.
I think even that wouldn't be on the same scale. What's the connection between moulding plates for bones to recover and deep sea pipes?
Well, interestingly enough, the main connection is that effectively the same material that we use for our trauma composite plates is the same material that's wrapped around a pipe that sits at the bottom of the sea. If you imagine a section of normal pipe, it then has the carbon fibre wrapped around the pipe and laser sintered onto it, and enough strength to sit at the bottom of a seabed and not get crushed.
So it's amazing some of the things you need in the bone case, which is strength and flexibility, is also what you need under the sea.
Yes, yeah, effectively, because the longest one they do currently is a 6 kilometre continuous length of pipe. So that comes on a big spool, which is designed to go on the back of a big ship and enables them just to almost just spool it off the back of the ship into the sea. Quite a substantial depth there, and it's still flexible enough to drop in and it doesn't break. And then previously the only other way is to have long rigid lengths of pipe, and then they'd have to have another ship next to that where they could do the welding and then launch it into the sea in segment, as they go along, where with the pipe it's just spool it off as the ship sails along.
And how did you get into this? I mean, what led you to become an engineer?
I've always had that curious mind. As a young child, I used to take things to bits just to see how they'd work. And obviously sometimes you used to drive parents mad because then I couldn't work out how to put them all back together. But it was that interest of looking at things and seeing how they work. And I always wanted to do something in the hands. So that's, I think, how I got stuck into engineering and went and did an engineering apprenticeship as a toolmaker.
And I find it quite interesting reading about your history, because you left school at 16.
Yeah.
And how important was it coming for an apprenticeship route to get into engineering?
I was never sort of an academic kind of person, and I find that for me a much more valuable way of learning. Getting my hands, getting stuck in, working out how things work. And also I think key to a lot of that is things will go wrong, things will fail, things won't go as you planned, but as long as you can not get defeated by that and just learn from it, then go on and improve things better than just head stuck in a notebook.
I guess society has this hierarchy around engineering, doesn't it? And the vocational studies, the sort of route you've come through, which is a much more practical route, is, I'm afraid, looked down on, isn't it, in a way? And university is held as this sort of gold standard everyone should do, and we need more than people who can just do degrees, don't we?
Yeah, and I think it's something that's always stuck in my mind with this, was that the firm, when I sort of started my apprenticeship, kind of was quite cyclic. They went through phases where it was like, right, we want apprenticeships because they learn on the job, they develop, they learn through the failures, and then it was like, well, we want people that have been to university and learn everything and know everything. And every credit to people that go to university and get these degrees and are very academic. I don't judge them, but I always remember when I was an apprentice, we had a young design academic come in. He'd been through everything university and everything else, and he'd done this drawing for this tool. And when we actually come to make it, the tool wouldn't really make as the drawing, because he'd sort of lived in all this drawing world instead of living in the world of making stuff and learning how things work and function. So I guess it's one of those, there's benefits to either side of that coin, but yeah, very much for me, I'm more biased towards that learning environment and learning as you go and developing your skill sets as you mature through an apprenticeship.
And the reality is that engineering actually needs both, doesn't it? I mean, it's great if you get someone who brings both those skills in one go, but actually engineering is usually about teamwork, and actually you need both viewpoints. And I think that's where creativity can be, is the two different perspectives on how to solve one problem.
Yeah, I think very much so, because I think a lot of, probably like myself, people that been through learning on the job and doing things are very much biased towards let's try it, whereas someone who has maybe been a bit more academic and learnt stuff and knows stuff are probably there just to rein us in a bit and go, well, actually that's probably not likely going to happen, so rule that one out, but go try this one instead. So yeah, very much a bit of both, and I think that's how you get the best results.
So before we did the podcast, we asked you for a quote that you thought was interesting and defined some of the things you do, and you've picked something by Barack Obama, which is, you can't let your failures define you, you have to let your failures teach you.
Yep.
Why is that relevant to what you do?
I think it's just like sort of a lot of our stuff is, so for instance with our plates, there's no written textbook out there really for our plates to say how that layup should be. No defined laws or rules as to how you make one of our plates and how you decide what angle those fibres are in there to give you the best results. So it was very much like, well, I've got some understanding, an idea of what may work, but fundamentally we need to make it, we need to test it, we need to see if it fails, how did it fail, and what do we need to change to try and make it achieve either the correct flex failure, as in how much can you bend it, or one of the fundamental ones that we also consider is what we call torque through. So when you insert a screw into it, how tight can you insert that screw into it? And a lot of that can be done by just changing the angles of the plies in the layups. And unless you test it and find out how it fails, then you don't really understand how it works and how you can make it the best it can be.
And I guess as these are going in people's bodies, you want to really understand that failure on the outside, because you certainly don't want to have to try and understand it when it's inside someone's body.
Yeah, well, to a degree, yeah, because obviously we need to get it as safe as we can, test it to check. We've done everything we can in sort of the virtual world and the test world, but how that migrates into real life with real patients, there's no model for that or no other way of doing it, because no one person moves their hand or wrist the same as another person.
I think that's one of the fascinating things when I hear about people working sort of devices that are used in medicine, like the trauma plates, is that you are in the end interfacing with humans who are quite awkward to work with from an engineering point of view. They're kind of squidgy and rigid bits and moving bits.
Yes.
And people probably do odd things as well.
And they're not all the same.
And yeah, that makes the engineering, I think, in a sense, engineering something like a car, though it's very complicated, it's probably a lot easier because it's all controlled, non-biological parts.
Yeah, and I think, like I said, we have another sort of side of the business where I think maybe fallen foul of trying to engineer something too well, in as much that we sort of developing a plastic replacement knee. So historically they've always been metal replacement knees, so we're developing them out of plastic. They're injection molded and with all the tools, and we work to microns on that. And then you think, well, I've seen the surgery of how they put a metal knee on, and it's not pretty and it's not delicate and it's quite a brutal surgery. And you think, well, we're working to microns. A human knee is not the same in every patient. There's got to be that room to be able to fit the thing. And it's just, I think sometimes you've been in the danger of over-engineering something.
So did I understand right then, you've actually watched surgery? Is that to kind of understand what happens?
Obviously, through the nature of our business, we need to understand things like that. So one of our design guys actually went out to America and sat through where they were doing cadaver studies as such. So they implant these devices, but the patients are no longer with us, so it's just the bodies that have been donated, and it's just so they can assess how it actually works on going on to a proper knee within a body, because again, there's only so much you can do with simulators and software. There's no substitute for the real thing.
Yeah, as soon as you mentioned cadaver, it made me think of old acoustic engineering studies on deceased people, until they found out the ear is very active and changes a lot when it's alive, and therefore kind of rendered these studies rather more pointless.
Yeah.
But yeah, colleagues of mine who are now retired used to work on cadavers. I can't quite imagine it.
No, I can't. I can't personally imagine. I've seen one of our trauma plates that we're making. They did an early cadaver with one of our plates, and they sent us pictures of the plate in situ and on someone's wrist, and it was more just to see how the screws had behaved, because again, it's simple things as well, which you don't necessarily always think about. But we do all our studying and testing, putting a screw in and everything else in sort of dry condition in a lab. Yet when you go to a cadaver or a human body, there's moisture in there, there's fluids, there's blood, there's tissue. So they sent us some lovely pictures of how that looked.
Yeah, I think enough from dead bodies.
Sorry.
And it's interesting that I was reading about the porous implants that your company's currently working on, and 3D printing, because actually I'm working in acoustics. I work on porous materials, nothing to do with bones, and I also work on 3D printing with stuff. So why do you need a porous 3D printing capability?
So the material that we use is basically a medical grade plastic, and it's for basically spinal wedges. So when patients have a lot of discomfort with vertebrates in the spine, and quite often they do a spinal fusion, and that involves putting an insert in between the two vertebrates and allowing bone to grow onto that and fuse those two vertebrates together. Obviously the patient has a stiffer back, but then they get rid of all the pain. And we already have a spinal cage in the market that's made out of medical grade plastic, and it has an additive within that helps the bone grow onto the material. Whilst it's great to have bone on growth, if you can then get bone in growth, then it's making that fusion process a whole lot better.
So the patient's bone will actually grow into this spine implant, and that will make it fuse and presumably more robust and strong.
Yes.
And more successful.
Yeah, it will do. So instead of it just growing around it whilst that worked, if you can get it to grow within that insert, then you're going to have a lot more bone. There's a lot of push in the sector now where they're doing the same with titanium. So they're doing this porous titanium through the 3D printing process. So I guess some of it is to, still remain competitive within that market. Our material as such, what we class it is called Peak Optima Ultra Reinforced, is out there, been used in patients. And interestingly, there was one recently, a prime athlete had a horrific injury. He was a runner, and he had what we call a femoral nail, which is basically an implant that goes down inside the femoral on your leg, and he specifically chose our material. It ended up where they stated that it would be unlikely if he ran again, but he's back up and running now. Not at the same fitness level yet, but his recovery period has been fantastic.
I mean, that's the great thing about engineering, isn't it? You're working on real everyday issues for people and making a difference to real lives.
Yeah, and I think that's what I love about to agree where we work at now, because it's an interesting field to be in.
And if I could grant you a superpower, have this some mythical ability to grant superpowers that I obviously don't have, but let's say I did, what would you go for and why?
It's a strange one, but I think I'd probably be like time travel. Not so much to probably go forward, but probably to go back and, see the great engineers and sort of inventors as such, and go back and see how they came to sort of do and develop the things that they did.
You wouldn't be fearful of the old time travel problem that you changed the past and something weird happened?
No. Watch too many Back to the Futures for that.
Yeah. And if you could change anything about engineering, is there anything you'd like to change?
I think the only thing sometimes is we get maybe too caught up in theory. I spend a lot of time of quandering, I guess, and going, well, will it work or won't it work? And now I understand that sometimes it's cost prohibitive and everything else. But yeah, I think I'm more get on with stuff and try it and see how it does, and then learn from that, and then maybe go into that deep dive of, right, well, it didn't quite work for this reason. So I think, yeah, sometimes it's just too caught up in the theory sometimes for me. or bureaucracy and red tape. And
so the Inventive podcast, which is obviously what you're doing now, is about exploring engineering through both fact and fiction. And we're teaming up with Emma Newman, who's a science fiction and fantasy writer, been on the shortlist for numerous awards. And
right.
Not only is she really interested in this sort of medical science use of engineering, she also has roots in the Northwest, so she comes from the same bit of the UK. So how do you feel about this idea of blending of fact and fiction and someone writing about what you do?
Yeah, I think it's interesting. It's quite novel, yeah, but I guess if I read a book or if I watch a film, if it's one that's based on sort of true facts or something that's happened and it's sort of a story around that, then I always find those kind of things much more interesting than something that's just completely made up. But then I guess it's just nice to see how would something that's actually factual sort of work out if you were to sort of play it out in a fictional world. So yeah, it's intriguing.
That's one of the most fascinating things of how far do they take their flights of fantasy and how much they stay with the facts.
Yeah, I guess it's how long they sort of let out in the field, looking up at the sky, dreaming up these wonderful things that they can dream up with their creative minds.
You can dream up some great creative engineering, though, as well.
Inventive.
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 Before I read my story, Healing the Fractured, just a few words on how I went about writing it. So there are two things that I love most about writing science fiction. One is looking at present-day technology and logically extrapolating where it could go from where it is now to in the near future. And in my book Planetfall, the protagonist is a 3D printing engineer, and so about 7 years ago I gave a lot of thought to how 3D printing technology could develop. And obviously, listening to Greg talking in the interview, I was immediately thinking about how the work that he does now could be refined and, I guess, streamlined and sped up and made more customizable in the future. The second thing I love about writing science fiction is looking at the interaction between humanity and technology. Now, in Greg's case, it's a very kind of practical application. He makes stuff using science that heals broken bones. So I wanted to try and find a way to look at the interaction between that technology and human experience in a different way. So that was where the story came from. For me, it satisfied both of those things that I love the most. I could think about how the process could be used in the future with custom scans and custom trauma plates for individual complex injuries being able to be made in a couple of hours. And also looking at the human interaction between technology and kind of political struggles that we have. How technology is being used against people, but also how people are using technology to unite against forces within the world that are harmful. I wanted to take a moment to examine that moment of bravery that every person who fights against a regime, all of those hundreds of thousands of people throughout history who have gone against tyrants, against fascism, all of them will have had a moment like Petra of absolute fear, of understanding the risk and doing it anyway. So I guess it was also a tribute to them. Healing the Fractured by Emma Newman. He wasn't dead in a ditch, or slumped over the wheel of the car, surrounded by broken glass in a dark country lane. They lived in one of the towns gobbled up by Manchester's suburban sprawl, for one thing. There were no dark country lanes for miles, and certainly none between their home and David's office. So Petra's imagination placed him slumped in a nook between huge dumpsters, behind a fast food restaurant instead, as if it was some sort of murder mystery producer trying to come up with a dramatic scene to start a show and impress the lead writer. She was tired of checking the phone for messages, tired of the tedious circling around the more plausible explanations for why her husband didn't come home last night. He probably wasn't answering his mobile because it had run out of charge and he hadn't noticed. He hadn't answered the office phone because he wore headphones when he worked, and there was no one else there to prod him. That was all. She'd barely slept, knowing she had a stressful day ahead, and now it was time to get up. The shower helped her to feel more human, and then the front door slammed as she was drying her hair, and she could hear David crashing about in his usual clumsy manner downstairs. Relief flooded her, making all those fears from the small hours of the morning seem ridiculous. Then the hairdryer cut out, and she swore. Flicking it on and off did nothing. It must have tripped a fuse. David was coming up the stairs 2 at a time, and then burst in with a small metal box under one arm. He rushed over to the smart home hub on the chest of drawers and yanked its cable out of the socket. "Where's your phone?" She took in the sweat on his forehead, his pallor. "Are you okay?" He spotted the phone on the bedside table, swept it up, took out the SIM card, and then dumped them, along with the hub, into the box. He put the box out on the landing, shut the bedroom door, checked the window was shut too, and sat on the edge of the bed. "David? What's going on? Did you turn off the power?" He nodded but offered no explanation. "Where were you last night?" "At work." "I was worried. Why?" "Have you seen the news, Petra?" "About the US diplomat?" "Yeah. I'm going to be printing a custom plate for him. Got the email at 2:30 this morning. It's a complex wrist fracture. The scan should be waiting for me when I get in." She loved her job. They'd been making trauma plates for years, but her refinements to the process enabled them to print custom plates in just a couple of hours. By the end of the day, it would probably be screwed into the bone over the diplomat's fracture, and she'd have the last bit of evidence she needed to argue for extra investment at the next funding round. She put the dead hairdryer down and went to sit next to him. "What's going on? You look scared. Do you know something about the crash?" There'd been all sorts of speculation about someone hacking the car's computer, as collisions were so rare now. But David specialised in encryption, not car safety systems. He twisted so he was facing her, looked into her eyes as he took her hands. He was trembling. "No, it's not that. I need you to do something for me." He swallowed, then reached inside his shirt pocket and took out a tiny plastic box, not much bigger than a SIM card. He held it between his thumb and forefinger so she could see it better. "I need you to put this in the plate you print for the diplomat, in one of the layers during construction, so it's hidden. And I need you to not tell a soul about it." She blinked and then half laughed, as if somehow that would burst this horrible bubble of tension and bring them both back into some sort of normality. But he remained deadly serious. "What is it?" "A computer chip. The box makes it look bigger than it is. I need to get it into the States, and this is the only way I can do it." Now she was starting to feel nervous. "Okay. I need you to start making sense. You're freaking me out." "I spent last night making this. Love, you know that I work in encryption. What you don't know is that I'm involved with a group of people who... No, you don't need to know that. Look, this box contains a chip that holds a public encryption key. The most powerful private encryption key I've ever made. And some software that basically lets the user piggyback off satellite comms. This, plugged into any decent motherboard, would let the user communicate with us, securely, from anywhere on the planet. I need you to help me smuggle it into the States, using the diplomat's trauma plate." "Are you a spy?" He laughed. "No. I'd be a crap spy, you know that." She gave herself a couple of moments, but it still didn't make sense. "But this sounds like James Bond rubbish." Despite that, she couldn't stop herself from working out how she'd insert the chip between two of the layers of carbon fibres without jeopardising the structural integrity of the trauma plate. Perhaps if it was small enough, and not near to any of the screw holes where it would be attached to the bone. It's theoretically possible, I suppose. The technical feasibility didn't worry her. It was the fact it was for the US diplomat. And the accident had happened during the first UK visit by a representative of the Neo-fascist America First Party that had recently seized power. Was David part of some dodgy plot here? He misinterpreted her silence. "So you'll do it?" She thought about the press attention the surgery was going to get, about how her boss had made a comment in the email about raising the profile of her work off the back of this case. Normally she'd be left to manage the printing of custom plates without anyone taking an interest. But this one? If she interrupted the print to insert something between the layers, it would be obvious to anyone watching. Of course, if they let the press in, God forbid, she could always print the last wrist fracture plate she'd designed and substitute it for the real one once the circus had left. But what if the press, or her boss, took an interest in the step before that, when she took the scan of the fracture and designed the plate for the print? She'd have to account for the size of the chip and some sort of protective casing and create a tiny cavity for it. Again, it was possible, but obvious to anyone looking. If she managed to stage something fake, she'd have to do that work after they'd gone, and then doctor the file after the print to remove the evidence. She felt the pressure of his gaze. I didn't say I'd do it. There are so many flaws in this plan I can't even... Like, how do you know that it will reach the right person? Petra, who's the leading complex fracture surgeon in Washington? The one most likely to remove the plate when the time comes. Her breath caught in her chest. Janelle! Oh God, you're doing this to get the chip to her, aren't you? So she can talk to us. Janelle was an old friend from university, one they'd known for years, a terrifyingly competent woman. America First had made VPNs illegal 3 months ago, effectively severing US citizens from anything not government approved, and chatting about politics with people in other countries was not something the fascists liked. The US now made China's internet censorship look relaxed. Janelle was one of many friends in the States that they hadn't heard from in weeks. It was so hard to have hope these days. This chip will help Janelle talk to lots of people. As soon as she sees that fracture is being treated with one of your custom plates, she'll make sure she's the surgeon in charge of his care, which she'll be already, and she'll know what to do. We saw this coming years ago, and we discussed using a chip like this to bypass censorship. We just thought we'd have more time. There are too many ways this can go wrong. What if Janelle doesn't guess what we've done? Then it ends up in a bin and I try something else. Won't they pick it up in a scan? You know my plates are radiolucent. He won't go through the same level of airport security that everyone else does. And even if he does, security staff will know about the surgery and assume that it's part of the plate or something. A surgeon won't, and they'll check the x-rays to see how the bone is healing. If it's not Janelle, it'll be found out. They'd know it was me, and they'd guess you gave me the chip. We'd be thrown in prison. But it's the best chance we have, love. Janelle could organise some serious resistance with proper internet access. There's no way for her to get something this secure in the States without ending up on some watch list. And let's face it, she's gay, she's highly educated, and spent a lot of time in the UK with people like us. She's probably on some list somewhere already. Yeah, and so it will be even worse for her if she's caught. She hasn't asked for this. Is it right for us to put her at so much risk too? He looked at her as if she was being stupid. Love, this is Janelle we're talking about. You know what she'd say if she heard you now. She did. Janelle would be appalled. David squeezed her hand. I know it's scary, but we have to do something, not just watch the news and talk about how horrible it is. You always tell me I spend my life with my head in the clouds, that my work isn't practical like yours is. Well, this is as practical as it gets. But this is like World War II resistance stuff, not our actual real life. How many times have we talked about how angry we are, how powerless we feel? He waved the tiny box at her. This is power. This is something we can actually do. But I'm not some hero. I'm just a materials engineer. She pulled away from him and went into the bathroom, feeling sick. What other secrets had he been keeping from her? Was he already in danger? Her mouth was horribly dry, so she brushed her teeth and then sat on the edge of the bath, knowing he was still in the bedroom and that she'd have to face him. But worse than that, she had to face herself. Was she really such a coward? Her pragmatic, practical brain chewed over the many ways in which this idealistic scheme could go wrong. They hadn't even discussed how to protect the chip while being removed from the plate after the fracture had healed, although she'd had some ideas about that already. Nor how to cover their tracks if the worst happened. She suspected there was no way to do that. Things were ugly in the UK too, with the right-wing government slashing human rights protections. How long was it before they lost the chance to even try this? And with the UK government still making friendly noises towards the new American regime, would they be extradited? The thought of being caught terrified her. But what if it worked? The fight against fascism manifested in many forms, not just armies, or internet memes, or exhausted historians begging media outlets to stop repeating the same mistakes over and over again. It was the women who hid families in their basements and attics. It was the bureaucrats who issued visas to allow people to escape. It was the office clerks who chose not to stamp certain papers, leading to death. Little people playing little roles with big consequences. They must have been scared, and the risk to her was far less than it was to them. She went back into the bedroom. David was still sitting on the bed, head in his hands, now looking defeated rather than stressed. "I'm sorry," she said softly. "I'll do it. But what if someone else gets hold of the chip? How do we know that it'll be Janelle using it if we get a message?" He smiled. "There's a single-shot password guess she has to get right for it to work, otherwise it's toast. It's the answer to a question. Which rock is everything built upon?" Both Janelle and David had called her their rock since university. It was what her name meant, derived from the original Greek. She was the one who was never late, who made sure everyone was okay and had what they needed, whether it was snacks for a road trip or a place to sleep to escape a toxic relationship. She smiled and took a deep breath, mustering her courage as she picked up the tiny box. "If I do get caught and sent to prison, and somehow you don't, you have to water my plants, okay?" He laughed as he wrapped his arms around her. "Deal."
Well, what an extraordinary response to the interview I did with Greg. And I've actually asked Greg to come back and listen to that. He's just listened to it for the first time. And I wondered what you thought of that sort of kind of description of the dystopian future that was extrapolated by your work.
Yeah, it was very interesting. Certainly great imagination by the writer.
Yeah, it's funny, isn't it? Because you're making these trauma plates and helping people out with healing, but there is Emma's imagining a James Bond kind of imagination.
No, yes, and I didn't realise I was having a sex change in this storyline either.
Well, I think that's an interesting thing because I've never had a story written about me. Now, of course, the characters are inspired, but not meant to be you.
Oh yeah, certainly interested in the context of relaying sort of my daily roles as such, and highlighting the fact that she was a materials engineer. So yeah, really interested in a good adaptation, I think.
One of the interesting things you said in the interview was you wanted to use time travel to go back in time, as a superpower to meet engineers from the past. But Emma's taken you into the future, hasn't she? And imagine someone in your kind of role trying to deal with authoritarian governments.
Yeah, I mean, as I say, it was to go back in time to see how things were done. But I guess going into the future sees how things have evolved and the changes that have happened.
I mean, where do you think your technology is going to be in 10 years' time? What can we look forward to from trauma plates, do you think?
Hopefully they'll be the way forward for, mending of bones and the benefits to the patients that brings. And I guess to a degree, how many bones can we fix in the human body with these plates? Because it's not necessarily always suitable for all the applications given the manufacturing process that we use.
And I just thought I should kind of really check with you. You're not involved in covert operations to topple an authoritarian government, are you? Are you?
Not to the best of my knowledge.
I'm glad to hear it. We might be on dodgy ground if you were.
Yeah, when I get that superpower, I'll look back and go there and then come back and make sure and let you know.
I'd like to thank Greg Bowie once again for allowing this story to be written, because I think it shows what a great thing you can do if you match fiction and fact together. You can extrapolate and make something really intriguing, building on Greg's great work. So thank you very much, Greg.
No, it's been an absolute pleasure.
Inventive.
We'd really like to hear what you thought about the spy story and also Greg's interview. You can get us through all the normal socials, but you can also contact us at our website, www.inventivepodcast.com. Now, the next engineer on Inventive sounds like she's auditioning to be Q from the James Bond movies. She runs a YouTube channel called Kids Invent Stuff and has made some fantastical devices like a motorised magic carpet, a crazy survival zorb and social distancing wings.
Unfortunately, they didn't allow me to fly. Maybe people just thought they were dehydrated when they looked out of the window and there's this woman with these giant wings walking along the side of the river.
She's Ruth Amos. And one of Ruth's fantastical inventions inspired author Jacqueline Yallop to explore the unintended consequences of engineering.
Mina realised she'd misunderstood. The problem wasn't keeping people at distance. That was only the beginning. The clever bit was bringing them close. That was where the invention lay. That's why the wings were engineered to fold.
Behind Inventive is a wonderful team, and thanks to all of them. Anna Scott Brown and Adam Fowler were the producers. Music was composed and performed by Brendan Williams. Animations and visuals were by Annabeth Robinson and Ben Warburton. And multi-platform and social media content was directed by Jill Davis. Now, as I record this remotely in lockdown from my attic, curriculum and career materials are being developed building on this podcast. They're being produced by NU STEM at Northumbria University, in particular Carol Davenport, Antonio Portas and Jonathan Sanderson. And when they're ready, you can go to our website www.inventivepodcast.com and find links. The Inventive project is brought to you from the University of Salford. It was funded by the Engineering and Physical Sciences Research Council, and the podcast itself is an Overtone production. So it's goodbye from me, acoustical engineer, Professor Trevor Cox.
Inventive.